And again, Japan. The land of, well, not that much land, but anyways. A construction company in there is using a building method called cross-laminated timber, or CLT, in many of its residential and public projects. This method involves using thick wooden panels, often about 90 millimeters thick, that are made by layering wood in different directions. These panels are made ahead of time, then delivered to the construction site and attached to concrete foundations using anchor bolts. In one example, they built a small one-story office using CLT along with local woods like cypress and cedar. The total floor area was about 725 square feet. CLT panels are strong enough to support the structure of a building and can also double as finished surfaces. This makes it possible to use fewer extra materials. In some buildings, such as apartment complexes like Arivakamobe 2 and the 4-story X-Ino, they mix CLT with traditional wood construction to get the benefits of both. Since the panels are prepared off-site, it helps speed up construction because less work needs to be done once everything arrives. They've had to work through some technical challenges though. Transporting the panels can be tricky, especially since not all of them are made locally. Rain and other site conditions also require careful planning during installation. In tight spaces, getting cranes in to lift the panels can be a problem too. And because the panels come in set sizes, architects have to plan their designs around those dimensions. Every project is planned carefully, with decisions based on how much weight the walls need to support, how wide the spaces are, and what safety rules apply. They've used one of their apartment projects as a kind of learning lab, allowing engineers and architects to visit and study how the materials perform. They treat CLT as one useful tool among many, depending on what each building requires. And here we are in Finland, analyzing a special type of beam that works together with different kinds of floor slabs, like hollow core, precast, concrete, poured on-site, steel deck, or timber. It sits inside the floor, so the structure stays hidden, and the overall height of the building can be reduced. In many buildings, it helps create wide, open spaces without needing a lot of columns. Beams typically span about 20 to 26 feet, and slabs can reach up to 42 feet. By keeping the floor system shallow, more usable space can be gained in each story. The way delta beam works happens in 2 steps. First, before the concrete sets, the steel beam handles the weight on its own. Then, after the concrete hardens, it joins forces with the steel through connectors and small holes in the beam. This teamwork between steel and concrete makes the structure stronger and stiffer. The holes in the beam also help transfer forces between the 2 materials. If any cables or pipes need to go through, that has to be carefully planned in advance. For certain projects, the beam can also be designed to handle twisting forces. One of its key features is fire resistance. Special fire-rated rebar is placed inside during manufacturing, helping it withstand high heat without needing extra protection underneath. In tests, the beam is held up for as long as 4 hours in fire conditions. Even in systems that combine wood and concrete, it has passed strict fire safety standards. Each beam is made in a factory using welded steel parts and reinforced on the inside. Germany again, and this mat system works by creating a floating layer between tile and the surface underneath. Unlike traditional methods, it isn't glued down, which means it can move slightly without passing stress to the tiles above. This helps prevent cracks and damage caused by movement, temperature changes, or minor issues in the surface below. It's especially helpful in areas where the base might not be perfect. The mat comes in 2 formats. Long rolls that are about 3.3 feet wide and over 65 feet long, or large flat sheets. It's around 1/8 of an inch thick. A full roll weighs close to 40 pounds, while each sheet weighs around 4 pounds. When installing, it takes just under half a gallon of mortar per square meter to fill the small shaped spaces in the mat. The adhesive layer above the mat should stay under a 1/4 inch thick. Tiles used with this system need to be at least 8 inches across, and the thickness depends on the material. Porcelain should be just over a 1/4 inch thick, ceramic slightly more, and stone at least a bit over 1/2 inch. It is designed to let any remaining dampness in the surface below escape through the joints in the tile. Its special design, with small cavity shapes and a textured surface, helps the mortar stay in place and improves bonding. Because the mat doesn't stick to the floor underneath, there's often no need to clean off all old glue or apply a primer, which can save time. Since the mat isn't attached to the base, it's easier to remove or replace the tiles later without damaging what's underneath. Germany. This formwork system uses a steel wire mesh covered on both sides with a layer of polyethylene film. It combines the strength of metal with a protective plastic layer, creating a panel that holds its shape during concrete pours. It comes in different sizes, with widths ranging from about 24 to 71 inches and lengths around 89 to 96 inches. The wires are spaced to handle different pressure levels, and panels can be delivered flat, shaped in advance, or adjusted on site. When connecting panels, a small overlap, usually around 4 inches, is used, and they're held together with wire ties or welded mesh. Once the panels are in place, concrete is poured directly against them. They don't get removed afterward, so they stay as part of the structure. This makes the process faster and removes the need to strip, clean, or store formwork after use. It's often used for foundations, edge beams, slab edges, curved shapes, and sections that need a clean break between concrete and soil. Installation begins after the foundation area is prepared. Panels can be cut or bent to fit the shape of the site, then fixed to the rebar or base using standard tools. During the pour, the steel mesh supports the pressure of the concrete. The plastic layer acts as a barrier between the mesh and the soil. Because the panels stay in place, there's no need for extra storage or return trips for formwork. They're compact, easy to move, and require no extra equipment. The plastic film includes recycled material, and because nothing is stripped away, there's no leftover waste. This Belgian system lets bricks connect without using any mortar, glue, or cement. Instead, it relies on specially designed plastic pieces that snap the bricks together from the top and sides. The bricks are made with small holes that fit these inserts perfectly, creating a clean and even look with narrow gaps between each one, about 1/8 of an inch. Behind the outer wall, metal anchors help hold everything in place by connecting it to the structure inside, like a concrete wall or steel frame. According to many, walls built this way can handle about twice the pressure of traditional brick walls. Putting the wall together is faster than the usual method because there's no drying time. Bricks just click into place, and the job can move along even if it's cold or rainy outside. It also takes less training to install, which helps save time and labor. Since there's no mortar, the bricks don't get those white stains you sometimes see from salt coming through. This system has already been used in several types of buildings, like houses, offices, and schools, covering more than 10,000 square meters across Belgium and the Netherlands. One big benefit is that the wall can be taken apart later. The bricks and connectors can be reused several times, which helps save materials and reduce waste. It also cuts down on cement use, which lowers the project's carbon footprint. In some cases, reports say this system can reduce carbon emissions by up to half. Next, a fresh, deep inhale in Switzerland. And here we're looking at a system used to build 6 timber modules, each made from beams with unique shapes, so 487 in total. Each beam can weigh up to 121 pounds. No external scaffolding is needed because the robots themselves created the reference points for where each piece should go. Look into an installation process, and the whole time it took is about 12 hours. But while robots did most of the work, people were still needed at the end to bolt the beams in place. Seems like everything starts with a digital model. Designers enter basic information, like where walls go, where the beams need to connect, and how the structure will carry weight. From there, a computer program figures out the best way to arrange the beams in 3D space. It also considers what's possible to build and how the parts will fit together. If anything changes in the design, the system updates everything, from the layout to the files used by the machines, so the build stays on track. Looking at arms picking up each timber beam. One robot cuts the beam to the right length using a CNC saw, then drills or mills the holes where needed. After that, the robot positions the beam in space. The system avoids crashes with other parts by adjusting the robot's movements as it goes. Sensors check that everything lines up, and if there are small errors, the system corrects them during the build. People step in at the end to connect the pieces with bolts. And, in Liechtenstein, I hope that I pronounced that correctly, there is this non-explosive demolition agent that when mixed with water and poured into drilled holes, expands to safely and quietly crack rock or concrete using internal pressure instead of explosives. It doesn't use explosives, meaning there's no noise, shock waves, or flying debris. And there are two types of it. One is a liquid for regular holes pointing downward, and the other is a thicker version that can be shaped by hand and pressed into holes that go sideways or upward. The holes used are usually between 1 1/4 and 1.5 inches wide and can be as deep as 20 feet. How far apart the holes are spaced depends on their size, but a common rule is 10 times the hole's width. The amount of material you need depends on how wide and deep the holes are. For example, you'd use about 1.08 pounds per foot for a 1 3/8 inch hole. To mix it, you need around 34 to 40 fluid ounces of water for every 11 pounds of powder. A power mixer is best to get the right texture, and it's important to pour it into the holes right after mixing. Temperature makes a big difference. On hot days, cracks can appear in just a couple of hours. In colder weather, it might take 2 or 3 days though. It works best between 41 degrees Fahrenheit and 95 degrees Fahrenheit. Once the material is in place, there's no need to block the holes, but covering the surface can help keep it from drying out too quickly. Because it doesn't explode, it usually doesn't require special permits or licenses to use. Next, we have some staples that reinforce and stabilize concrete or brick surfaces by stitching across damaged areas. The company says they come in different sizes. They're sold in packs of 5 or 10, depending on the model. 3 is labeled for use in cracks that are between 0.04 and 0.2 inches wide. The measurements likely describe the size of the staple itself, or the space it covers. These staples are used to fix cracks in materials like concrete or brick. To install one, a small groove is cut across the crack. The staple is placed so that each side goes into opposite edges of the break, and then the area is filled with something like mortar or epoxy. When everything sets, the staple helps hold the surface together and keeps the crack from opening up more. This follows a method already used in the construction field called crack stitching. What seems to make them work is the combination of physical anchoring and the bonding material around them. When everything is applied properly, the result is a stronger repair that can handle some movement or stress. And the number of staples and how far apart they go depends on how long and wide the crack is, and how much weight or pressure the area takes. In Belgium, we've got a ground screw foundation system that anchors directly into soil to support decks and terraces without the need for concrete. It replaces traditional concrete footings by using a 25.6-inch long ground screw that anchors directly into the soil. There are two versions available, the 65XL, which sticks out about 5.9 inches above the ground, and the 65S, which sticks out 1.6 inches. Each kit includes 4 ground screws, top plates, adapters, extension rods, and other connecting pieces to help build a stable base. The setup allows for easy height changes and connects to wood joists or tile deck systems. After installation, the screw holds the structure steady by spreading the weight into the ground. Since it's driven into the soil instead of being set in concrete, there's no need to dig or wait for anything to dry. Once the screw is in place, you can build on it right away. The adjustable parts on top help keep the surface level, even on uneven ground. If more height is needed, extra rods can be added to lift the support higher. Everything can also be taken apart later if changes are needed without tearing up the whole area. It's useful for spots where pouring concrete might not be an option, or where a more flexible setup is preferred. The XL and S versions are mainly different in how much sticks up above the ground, which affects how the other parts fit. Once the screws are in place, no drying or setting time is needed, and the rest of the structure can be built right away. Next, we go in New Zealand to see a system used to set up concrete foundations like slabs, footings, and walls. Instead of using wooden stakes and angled braces, this one also uses metal parts that you attach next to the formwork. These parts are held in place with metal stakes and then connected to the wooden boards using screws or bolts. Once everything is in place, you can adjust the height and angle using handles built into the units. This helps make sure the forms are straight and level before the concrete is poured. Some versions of the system include bubble levels to help with alignment. After the concrete sets, the metal parts and stakes are taken out and saved for the next job. Because the same parts can be reused many times, there's much less wood and nail waste left behind. People who've used the system in the field say it can cut setup time in half and make leveling up to 80% faster. Taking everything apart afterward is also quicker. Some say 60 to 75% faster. The system can reduce job site waste by up to 90%, which is useful on sites where managing leftover materials is a hassle. Using Prob Brace also means less heavy lifting and fewer chances of getting the angles wrong when setting up forms. But like anything, it works best when installed properly and in the right kind of soil. In Liechtenstein, sorry for my pronunciation, working with your arms above your head for long periods can really wear you out. Wait, isn't that the same in New York too? I guess. And so this shoulder support device helps take some of that weight off by using a simple mechanical system. It doesn't run on batteries or motors. Instead, it uses springs and cables to shift some of the strain from your shoulders down to your torso and hips. That way, your upper body doesn't have to do all the work. It weighs about 5.3 pounds and fits around your upper body like a vest. You can adjust it with straps around your waist, chest, and upper arms, so it can fit different body types. The large size fits arms up to 16 inches around and is about 17.8 inches wide and 9.8 inches long. Padding in the right places helps keep it comfortable while you're wearing it for a full shift. When you raise your arms, the support system kicks in and helps hold them up. It doesn't give you extra strength, but it helps you stay in that overhead position longer without getting as tired. It's especially useful for work like installing ductwork, ceiling grids, pipes, or electrical cables, anything that keeps your arms up for a while. Studies show it can reduce the effort your muscles need to hold your arms up by nearly half. That means you can work longer with less strain. Since it doesn't have any electronics, there's nothing to charge or plug in, and it's easy to use right away. If needed, different people on the crew can use the same unit by adjusting the fit. And in Zurich, this concrete ceiling slab covers about 860 square feet and is made from 11 separate pieces that fit together to span 39 feet. It weighs only 20 metric tons, about 70% less than a regular concrete ceiling of the same size, but it covers a relatively large area. Its thickness changes depending on where more strength is needed, going from as thin as 0.8 inches to just over 5 inches, and is made with a special type of concrete designed for digital construction and reinforced with standard steel bars. Built-in channels for air, electrical, and plumbing systems are part of the design, so there's no need to add extra ceilings to hide them. What makes this slab different is how it was designed and made. Most concrete ceilings are flat and use more material than necessary, just to be safe. This one was shaped using computer models that calculate exactly where the concrete is needed for strength. That means less material is used, and the shape naturally follows the flow of force across the surface. The result is a ceiling that's not just efficient, but also has a unique, curved look. To create the complex shape, large 3D printers were used to make the molds out of sand. These molds were made using a process called binder jetting, which binds layers of sand together to match the design. The printer used, one of the biggest available, allowed for very accurate details. Although the molds can't be used more than once, they make it possible to create shapes that traditional methods can't handle. UK, a ready-to-use channel and bracket system made to hold up pipes, cables, ducts, and other building services. The system includes a metal bracket and 2 interlocking tracks that connect without tools. Its bracket lengths range from about 6.7 inches to 57.9 inches, giving different options for space and load needs. It can safely handle around 220 pounds in one orientation and 154 pounds in another, with evenly spread loads reaching up to 440 pounds, depending on setup. This channel's main advantage is how quickly it can be installed, about 6 times faster than older systems. The bracket locks in place securely and can be moved or adjusted without using nuts or bolts. The tracks have measurement marks every 2 inches, helping installers line things up accurately. Any extra track can be snapped off instead of cut, which keeps the job site tidy and reduces waste. Once the system is in place, it's easy to make changes or adjust heights without taking the whole setup apart. There are several versions to fit different spaces. The standard version works for most ceilings, the side-loading option helps when space is tight, and the low-profile model fits shallow ceiling areas. There's also a version designed to keep power and data lines separate. Add-ons like conduit clamps, J-hooks, and vibration dampeners make it more adaptable to different projects. Each bracket can hold attachments on any of its 4 sides, giving flexibility in how equipment is positioned. The parts come packaged in a way that makes them easy to move and store at the job site. Back to the United States. To home, of course. This concrete wall system uses large, heavy blocks to hold back soil and create solid retaining or freestanding walls. Each block is made from high-strength concrete, usually rated above 4,000 psi. They come in sizes like 28, 41, and 60 inches wide, and can weigh anywhere from about 1,500 to over 3,200 pounds. There are different types, including solid and hollow core blocks, as well as special pieces like corner units, caps, and planters. The faces of the blocks are molded to look like natural stone, with textures such as cobblestone, limestone, ledgestone, and kingstone, which helps avoid a repetitive or artificial appearance. In many cases, walls can be built up to 18 feet high without using reinforcement, as long as the ground conditions are favorable. If taller walls are needed, especially up to around 21 feet, hollow core blocks can be used. For even higher walls, like those over 60 feet, a reinforced system is used. This involves inserting geogrid into slots in the blocks, helping tie the wall into the surrounding soil. Freestanding walls, which don't hold back soil, are usually built up to about 7.5 feet high, unless extra anchoring is added. Installing these walls involves planning for things like drainage, foundation depth, and how the blocks lean backward slightly for added stability. Drainage features like gravel layers and filter fabric are included to help keep water from building up behind the wall. The blocks are designed to fit together securely and stay aligned over time. ZIPBOLT again, and a new building method from a company uses special technology to help workers place bricks or wood blocks with extremely high accuracy, down to just a few millimeters. It works by combining digital design with augmented reality, which shows workers exactly where each piece should go. A camera watches the structure as it's being built and compares what's already in place to the plan. Then it shows small adjustments to help guide the next piece. This method allows buildings to have more interesting shapes, like curves or tilted surfaces, without giving up strength or stability. Instead of building only straight, flat walls, architects can create patterns, textures, or surfaces that change with light and sound. To help everything fit, blocks are sometimes shaped ahead of time. In one example, wood pieces were cut into specific shapes to fit a sculpted wall inside a cafeteria. Another project in Greece used bricks with gaps between them to create a shifting light effect on the outside of a wine cellar. Before construction begins, architects design everything in 3D using computer software. That design is then uploaded to the system, which helps guide construction on site. Workers use screens or AR headsets to see exactly where and how to place each piece. As each block goes in, the system checks the position and gives real-time feedback to keep things on track. This way, even though people are doing the building, they get the kind of precision usually expected from machines. Back to the UK, back and forth. Joining two kitchen countertops can be tricky, but this fastener system makes the job a whole lot easier. Instead of fiddling with nuts and bolts that eat up time, it lets you tighten the connector from underneath using a drill. Thanks to its gear-driven head, you can lock it in place with one hand and get a rock-solid connection fast. It comes in different models to match various countertop thicknesses, from thin half-inch boards to those over 1.5 inches. Each version uses different bolt lengths and driver heads. The compact version, for example, has a 4-inch bolt and uses a T25 Torx bit. The standard version uses a 6.5-inch bolt and a 5mm hex bit. All bolts are made from zinc-coated steel, and some models include reinforced plates to handle higher torque when tightening. Installation starts by routing matching slots into the underside of each countertop using a jig or template. These cutouts make space for the bolt's head and shaft. Once the recesses are done, the bolt fits snugly into place. Plastic clips hold it steady so it won't fall out, and wood biscuits help line up the countertops perfectly. Then, from underneath, you tighten the bolt using a drill and the supplied bit. The gear mechanism pulls the two sections together until tight. No struggling with nuts, no awkward angles, just smooth, controlled clamping. Spain, looking at a solar thermal system that works by turning sunlight into heat. It's designed to look just like regular slate roofing or wall cladding, so it doesn't stand out or change the appearance of a building. Instead of adding bulky panels on top of a roof, the system replaces some of the roof tiles with special slate modules that collect solar energy. The heat can then be used for things like heating water, warming rooms, or heating a pool. The system connects to regular hot water tanks and heating systems. To work properly, the roof needs to have a slope steeper than about 22 degrees, roughly a 5 to 12 pitch. Each module is made to match the surrounding tiles, so everything lines up and stays watertight. The system is modular, meaning it can be scaled up or down based on the energy needs of the home. In terms of performance, this system can supply as much as 2/3 of a home's yearly hot water demand. In real-world examples, results can vary depending on the setup and location. One project managed to cover 57% of its hot water needs and reduced carbon emissions by around 990 pounds per year. On average, every 10.8 square feet of slate installed cuts about 200 pounds of CO2 annually. Since the slate holds heat well, it also helps keep temperatures more consistent throughout the day. And an American system is made to help steelworkers safely climb up and down steel columns while staying connected the entire time. It combines 3 main parts: a foot frame that straps onto the worker's boots, a claw that grips the column, and a lanyard that ties it all together. The setup can hold up to 250 pounds, including tools, and if the worker slips, it stops the fall within 2 feet. The foot frame is made from tough steel and has a jaw that grips the column like a clamp. It works sort of like climbing stairs. Each step locks into place as the worker moves up or down. The bottom of the frame has a textured surface that helps the worker keep their footing, even if there's oil or dirt around. It straps on quickly, using strong webbing and a heel bar to keep it secure. The claw is what follows the worker as they climb. It stays in place along the column and locks in if there's a sudden drop, keeping the worker from falling too far. The lanyard connects the claw to the safety harness worn by the worker, keeping everything linked together while they move or work. This setup is mainly used during steel construction or repair jobs, like putting up columns, doing inspections, or making adjustments high off the ground. It removes the need for ladders or heavy equipment in some situations. Since it supports both feet and keeps hands free, workers can focus better on tasks like welding or bolting. Next, look into some French fancy fences made from welded steel mesh panels. But why we're looking at them? Let's find out. They're attached to metal posts using secure clips or brackets, forming a strong and stable structure. So, not only be a nice sight with added decorative panels, but it will also be incredibly durable. The fence will be easy to maintain and even easier to install, even without any construction experience. But if you need more privacy, there are slats available in PVC, wood, or artificial greenery that can be added between the mesh. For decorative touches or extra strength, metal cages called gabions can be filled with rocks or other materials. Gates come in standard 2-panel styles that swing open from the middle, and custom sizes can be ordered. There are also a variety of parts like posts and connectors to complete the setup, and electric motors can be added to automate gate opening. By the way, gate automation has always felt so fancy, no matter French or Polish, but a solid example of gate automation is the Ontramatic IonXBU system. It runs on 24-volt power and includes 2 12-volt backup batteries. If there's a power outage, the gate can still work using battery power. It functions reliably in temperatures ranging from 5 to 122 degrees Fahrenheit, which covers most weather conditions. Belgium again. Ever wondered what's hiding under that perfectly green patch of synthetic grass? It might be drain base doing all the heavy lifting. So there, we're looking at a smart drainage tile system designed to go under synthetic grass and keep it dry, stable, and in place. Each tile measures about 24 inches by 24 inches and is just over an inch thick. One tile covers almost 4 square feet and weighs a little over 2 pounds. It's made entirely from recycled high-density polyethylene, a type of plastic that can handle sunlight, freezing temperatures, and chemical exposure without breaking down. Every tile has more than 1,000 small pins on top that help keep artificial grass from shifting. There are also 9 flexible zones built into each tile, so it can adjust to slight bumps or dips in the ground underneath. The layout underneath follows a checkerboard pattern that spreads out weight evenly, and the pieces connect with a click system that can handle slight changes in size caused by hot or cold weather. Each square yard of the system can hold nearly 8 gallons of water before it slowly drains into the ground below. Looking closer, we see that it channels water through the turf into its grid and down to the soil, preventing puddles and adding insulation. Installation involves digging, leveling, laying a weed-blocking fabric, adding gravel, and snapping the tiles together. Tiles can be trimmed to fit and topped with artificial turf, which is secured with caps and screws. In Atlanta, Georgia, a fabric-formed concrete system, creating harsh, durable, erosion-resistant linings and structures for underwater and slope protection. It works by using specially designed fabric forms that are filled with a strong concrete mix. Once filled, the forms create solid concrete linings or blocks that take the shape of the fabric. These structures are installed directly on-site, without needing traditional wooden forms or steel reinforcements. The result is a single, continuous concrete piece shaped to fit the area where it's used. Depending on the design, the thickness can range from 3 to 10 inches, with weights between 34 and 90 pounds per square foot. Some of the largest versions, like HYDROCAST units, can weigh up to 70 tons. There are different types of HYDROTEX systems, each made for a specific purpose. Some include built-in drainage features to let water pass through, which helps lower pressure underneath the concrete. Others, like the uniform section, form a smooth concrete surface that's good for channels or slopes. The EnviroMat types are made with gaps that allow plants to grow through the concrete, which can help blend the structure with the surrounding environment. For areas with strong waves or water movement, HYDROTEX includes block-style designs that can shift slightly and stay in place without breaking apart. Some forms are made to wrap around underwater pipes or support piles. I think we know what you're thinking, but before installation, engineers often help design the right version based on local conditions, like water speed, soil strength, and slope. Each project uses forms that are adjusted to match the specific challenges of the site. Netherlands or Holland, and here we're looking to an insulation material made from a type of polystyrene foam called XPS. It's formed into thin, flat sheets and mostly used inside buildings. The sheets usually measure about 49 by 31 inches and come in thicknesses of 3, 6, 9, and 12 millimeters. Thinner sheets are denser, around 40 kilograms per cubic meter for the 3 millimeter version, and about 33 kilograms for the 6 millimeter. In terms of strength, they can handle pressure up to 0.10 megapascals for the thinner version, and about 0.15 megapascals for thicker ones. Their ability to resist heat loss depends on thickness. Thinner sheets offer less resistance, while thicker ones improve performance, reaching R values up to 0.40. These panels stay stable in temperatures ranging from -76 degrees Fahrenheit to 158 degrees Fahrenheit. They don't absorb water and resist vapor well, with ratings that show they can handle damp air without changing shape or structure. They also handle heat safely, with melting points above 320 degrees Fahrenheit and ignition points reaching over 900 degrees Fahrenheit in the absence of open flames. Some sheets meet standard fire safety classifications, depending on the version. The material is typically added as a second layer of insulation inside walls, ceilings, or floors. It works especially well in places where there isn't room for thicker insulation. Depending on the thickness used, it can reduce heat loss through walls by 17 to 38%. When placed under flooring, it can also help reduce footstep noise by up to 16 decibels. The sheets are stable even in changing humidity and don't support mold growth. They're also tested to have very low emissions, making them safer to use indoors. Germany again. This insulation plaster uses aerogel, a material known for its excellent thermal resistance, mixed into a mineral base. It's designed to help keep buildings warm by limiting heat loss, even when only a thin layer is applied. The material has a low thermal conductivity of about 0.036 watts per meter Kelvin, which means it doesn't let heat pass through easily. It also has a relatively low weight and can be applied in layers from around 0.8 to 2.4 inches thick, though no more than 2 inches should be added at once. The plaster also allows vapor to pass through and can take in and release water naturally, which helps walls stay dry over time. It has a compressive strength of around 0.5 newtons per square millimeter and doesn't burn, which makes it safer for use in buildings. To get the best results, it typically needs around 1.8 to 2.0 kilograms of material for every square meter of surface per centimeter of thickness. The mix includes white cement, hydrated lime, mineral additives, and aerogel. It's especially useful in buildings where there isn't enough room for traditional insulation panels, or where the appearance of the walls needs to be preserved, like in historic buildings or older homes. Thanks to the aerogel, even a thin layer can help improve the building's energy efficiency. The plaster can be applied by hand or machine. After putting it on, the surface is smoothed and lightly textured, so the next layers can bond properly. There's usually a waiting period of about 1 day for every millimeter of thickness before adding the next layer. Further, there's a tough, eco-friendly ground grid made from recycled plastic that keeps driveways strong and green. Each panel measures about 25 inches by 21 inches and is around 1.5 inches deep. It weighs roughly 3 pounds and has thin walls between the cells. To cover 1 square meter, you need 3 of these panels. The material is treated to resist damage from sunlight, so it holds up well outdoors. When installed and filled correctly, it can support up to 150 tons per square meter. In fact, this system is meant for grass or gravel areas where vehicles or people need to pass without damaging the ground. The 1.5-inch deep cells protect grass roots and let the grass spread naturally, helping it grow thicker over time. Setting it up involves a few steps. First, the ground underneath needs to be dug out and packed down so it's even. Then, about 4 to 6 inches of crushed rock go on top. In heavier use areas, an extra support layer can be added between the ground and the rock. A fabric layer might also be used to stop fine particles from moving up through the layers. On top of that, you add a bedding layer, either a sand soil mix for grass or small stones for gravel. The panels lock together and can be cut to fit curves or corners. Grass-filled areas are slightly recessed, allowing the lawn to grow in. Gravel-filled sections stay level with the grid. While the area can be used right away, it's best to wait a few weeks for grass to fully grow in. Next, instead of digging large holes and pouring concrete, this anchoring system is designed to be driven directly into the ground. It uses steel parts that are available in different lengths, from about 12 to 40 inches, and widths ranging from 1.6 to almost 4 inches. There's even a square version. With more than 300 variations, the system can adapt to different soil types and weight needs. Installation is done with a hammer tool, pneumatic, hydraulic, or electric, which pushes the anchor into the ground, making the process quicker and often cleaner than traditional methods. Different models are made for specific uses. The alpha version works well in hard ground, like soil, gravel, or asphalt, and doesn't need any concrete. City is used in urban areas on paved surfaces, and still needs a small amount of concrete, but far less than usual. Beta is designed for clay-heavy soil, and country is meant for fences and other rural structures. The eKit model includes built-in space for electric cables and is used for things like charging stations or outdoor lights. For situations where concrete can't be avoided, there's a model called Betonamit that uses a minimal amount. The steel anchors are coated to help them last longer, and if a part wears out, it can be replaced without digging up the whole thing. There are also tools and accessories available to help with alignment and stability, including clamps, adapter plates, and support rings. Going to Japan and analyze a bit a humanoid robot. It stands 6 feet tall and weighs around 222 pounds and has 37 joints across its neck, torso, arms, hands, and legs, which let it move in ways similar to a person, and in some cases, even more flexibly. Some joints have more than one motor to give them extra strength, and cooling systems help it keep working for longer periods without overheating. Its waist and hips, in particular, can twist and bend far more than a human's, which helps it reach and operate in tight or awkward spaces. Our little friend can lift and move large construction boards like drywall or plywood. It's able to handle standard panels about 6 feet by 3 feet in size, weighing around 24 to 28 pounds. Even when its arms are stretched straight out, each one can hold about 6.4 pounds, which is more than twice as much as older robots in the same series. HRP5P uses sensors in its head to scan its surroundings in 3D. If its view is blocked, it switches to using a saved map of the area and updates it as it moves. It's trained to recognize different tools and materials using artificial intelligence and can still work accurately in dim lighting or when objects are hard to see clearly. All its movements and tasks are guided by advanced software that brings together what it sees, where it needs to move, and what it needs to do. Developers use a virtual test environment called Choreanoid to simulate how it works before trying it in real life. And finally, its software contains around 250,000 lines of code. Back to America at whisker markers, used a lot in construction and surveying to mark important spots like elevation points, property lines, or where underground utilities will go. They're made of flexible plastic and are about 6 inches long. Even if something runs over them, they bounce back into shape and stay visible. They come in bright colors like red, orange, pink, yellow, green, blue, and white, which makes them easy to see in busy or cluttered areas. On construction sites, workers often place these markers next to stakes to show where the ground should be cut or filled. Since they hold their shape, even after being stepped on or driven over, they're easy to spot from a distance throughout the job. When crews need to show where underground pipes or cables will go, these markers help guide the digging without being in the way. In areas with weeds, tall grass, or dirt piles, the bright colors make it easier to keep track of property corners or layout points. Workers also use them to mark lines for foundations, guideposts, or layout edges before any actual building begins. And, in this system, heating or cooling pipes are pressed into place between raised studs on rigid polystyrene plates, and then covered with a layer of screed, a type of concrete. The pipes, made from a plastic aluminum composite, range from 9/16 to 11/16 inches in diameter. Fully embedded in screed, they distribute heat or cooling evenly across the floor. There are 2 versions, Premium and Object. The Premium version includes built-in insulation that reduces both downward heat loss and footstep noise, meeting recognized quality standards. The total system thickness, excluding the top floor layer, is about 4.3 to 4.4 inches. Pipe spacing is adjustable from 2 to 12 inches, and layouts can be straight or diagonal. Additional elements like edge strips and ceiling materials manage expansion and isolate the floor from surrounding walls. Extra insulation can also be added beneath the plates if needed. Installation is fast. Pipes snap into place without tools, and large plates speed up coverage while reducing waste. Once installed, the system is stable enough to walk on during construction. It operates efficiently at low water temperatures, 95 degrees Fahrenheit to 113 degrees Fahrenheit, making it ideal for heat pumps. With even heat or cooling across the surface, the floor maintains consistent temperatures without hot or cold spots. It also connects easily to solar panels and smart home systems. Going again to Japan, the land of those tiny little porcelain cats with a belly description of good luck and those orange color foxes. Seriously, what are their names? What's up with them? Anyways, this helmet fan system weighs not even 10.5 ounces and runs on a 2,900 mAh battery. It has 3 speed settings: low, medium, and high, so the airflow can be adjusted depending on how hot it is. On a full charge, which takes about 6 hours using a USB-C cable, it can run for up to 12 hours on low, 8 hours on medium, and around 5 hours on high. The airflow can also be directed in 2 ways, either under the helmet or down towards the neck. It's made from plastic and flexible materials like ABS resin, TPE, and silicone. The fan usually attaches to the back or side of a helmet using a soft band. This fan system is designed to help people stay cooler while wearing safety helmets, especially during hot weather or long hours of outdoor work. Since helmets don't allow much air to flow around the head and neck, this fan helps push air into those areas. And further, looking at these ready-made exterior windowsills made from insulated polystyrene foam, about 0.79 inches thick, with a decorative, weather-resistant coating that mimics brick or stone. On the outside, they're coated with 2 layers. The first is a mix of marble chips and an acrylic binder. On top of that is a decorative layer that looks like brick or stone. This outer coating adds around 0.12 inches to the total thickness. They come in different depths, 3.1, 6.7, and 12.2 inches, with a height of about 18.9 inches. Matching corner pieces are also available to go around window edges. Their main job is to help keep heat from escaping through the areas around windows. When installed correctly, they help reduce the risk of condensation forming on the inside edges of windows. These pieces aren't meant to hold weight. They're there to protect and insulate parts of the wall that are often hard to finish properly. The foam used has good insulating ability, with thermal conductivity typically between 0.033 and 0.040 watts per meter Kelvin. The outer layer doesn't insulate much by itself, but does a good job of shielding the foam from sun and damage. To attach them, installers usually use adhesives designed for foam, and sometimes add extra fixings for support. The joints between pieces are sealed with flexible materials to keep water out. It's important that these sills stick out at least 1.6 inches past the wall surface. That way, rainwater flows away from the building instead of running down the wall. The surface textures match with the company's wall panels, so everything looks consistent.